Okay, we're college algebra. This is section 5.4, and in this section we'll be solving equations with radicals. So pretty straightforward three-step process. The first step is you want to isolate the radical on one side. Step 2 is you raise each side to the same exponent, and then step 3 you solve and check your solution. So let's just dive into some examples here. So this first example is 2 times the square root of x plus 1 equals 4. I want to isolate that radical, so I'm going to divide both sides by 2, which gives me the square root of x plus 2 equals 2. Square both sides, because that's how you undo the square root of something. The square root of x plus 1 squared is x plus 1. 2 squared is 4. Subtract 1 from both sides, and x equals 3. I'm going to quick check to make sure 3 really works. So here we would have 3 plus 1 is 4. The square root of 4 is 2. 2 times 2 is 4. So this answer checks out. Okay, this one is the cubed root of 2x minus 9 minus 1 equals 2. Again, I want to isolate the radical, so add 1 to both sides. I want to raise both. The way you undo taking the cubed root of something is to cube it. So we're going to cube both sides. The cubed root of 2x minus 9 to the third power is 2x minus 9. 3 cubed is 27. Add 9 to both sides. Divide by 2. X equals 18. Let's see if 18 works in the original problem. 2 times 18 is 36. 36 minus 9 is 27. The cubed root of 27 is 3. 3 minus 1 is 2. So that answer checks. It's really important that you do check your answers, because sometimes you're going to get extraneous solutions. All right. So let's go ahead and solve this equation. To undo the square root, I'm going to square both sides. And remember, when you square a binomial, the result is this squared. Multiply those together and multiply by 2 plus that squared. I'm going to get everything over on the left-hand side. 2x minus 7x is negative 5x. 1 minus 15 is negative 4. And this is factorable. The factors are x minus 7 and x plus 2. So if these are my factors equal to 0, then either x is 7 or x is negative 2. Or it could be both of them, but we're going to check both answers. So if x were 7, I just plug 7 in for x, and I end up with 8 equals the square root of 64. 8 is the square root of 64, so that one checks. This one, however, if I put negative 2 in, this would give me negative 14 plus 15 is 1. This would give me negative 1, but negative 1 does not equal the square root of 1. So x equals 2 is an extraneous solution. The next example we're going to work on is when you have radicals on both sides of the equation. So because this one's alone, I'm just going to go ahead and square both sides. So you're going to treat this just like it's a plus b squared. Treat it like a binomial. And when I square a binomial, remember it's going to be the square root of that, which is x plus 2. Multiply these together and multiply it by 2 as the middle term, and then plus this squared is the last term. So I want to isolate this variable, which means I'm going to get rid of x, subtract x from both sides, and 2 plus 1 is 3, so I'm going to subtract 3 from both sides. On the right-hand side, when I do that, negative x minus x is negative 2x. I still have this. I want to get rid of that, so I'm going to divide both sides by 2, which leaves me this. To undo that, I'm going to square both sides. which leaves me x plus 2 equals x squared. I'm running out of room, so I have to turn my paper. Put everything on the left-hand, or on one side, and set it equal to 0, which leaves me x squared minus x minus 2. And this is how that factors. Set each factor equal to 0 and solve it. X equals 2, x equals -1. And if you plug both of these into the original equation, -1 is the only one that works. X equals 2 is an extraneous solution. And, sorry, that is it for 5.4.